So today we're going to take a look at a lot of stuff basically inside the circle. We're going to look at chords, which chords would be the same, and then which arcs would have to be the same. Many ways that you can look at that. So this first one says in a circle, so this could be in just one circle or two congruent circles. And what do you think? These two circles that I have down here, would you consider those to be congruent? Now where are you looking to decide if they're congruent? Are you looking at the 110 degrees? I hope not, because I could put any angle in there. You should probably be looking at the radius. This one has a radius of 4, that one has a radius of 4, so are they the same? Yes, they are. They're pretty much going to be the exact same size. That's why they're congruent. It's saying, okay, so we have congruent circles. Two minor arcs, remember minor means that it's less than 180, yep, are congruent. Now, you may think this right there is a typo. It is not. That might be the most extreme case of mathematicians being lazy. That actually stands for if and only if. I think it's actually written out on yours. But if with two F's actually stands for if and only if. Because that happens so much in mathematics, we didn't want to write it anymore, and so we just put if with two F's. Okay. And some of you are still looking at me like I'm pulling a prank on you, but I'm not. That's actually what it stands for. The corresponding chords are congruent. Okay, so, well, we look at these two circles. Those look the same, right? What do you think about that chord and that chord? Would they have to be the same? Is really the question. And they actually do have to be the same because you agree this would also be 4 down there because that's also a radius. And then this one over here would also be 4. Are those two triangles you're looking at, are they congruent? Yes, they are, by side, angle, side, right? And so would those two chords have to be congruent? Yes, they do. And that means seeing basically AB is congruent to XY. That means the arcs are also going to be the same. Okay. So in other words, if I were to cut it there, and rip that off, do the same thing over here, cut it, rip it off, they'd be the same. Okay. Another way you probably could have looked at that one is because the angle there is the same. Now how about this first part? How can it be in just one circle? That's the one that gets some people. Well, what if I do this? And I put 110 degrees over there. Would this one in green that I just made be the same as the one in red over there? Yeah, so could it be in the same circle? It could be, as long as the chords are the same. And are those chords the same? Yeah. And so this arc over here would actually be the same as that one over there, because it could be in the same circle. It doesn't have to be two separate circles. But if it is in two circles, they better be congruent. Okay. Any questions on that? Basically, if the chords are the same, the arcs will be the same. Here it says in a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. Well, I look at it this way. Diameter, that's a little iffy. Basically, as long as the segment comes from the center, it doesn't matter. Because I could have started here and stopped right there, and as long as it hits at a right angle, it's still going to bisect it. It doesn't have to be a diameter. Okay. So as long as it basically comes from the center and hits at a right angle, it will cut the chord right in half. Because remember, that's what bisect means. So, well, in other words, can we determine DE? Remember, there's nothing above that, so that means find the distance from D to E. Is that actually something I can figure out then? Yeah, if this is getting cut in half, what's this bottom part then? 5. So how long is it from D to E? It's got to be 10. Okay. And again, all it has to do is come from the center. And basically what happens there is, seeing this is a right angle, it actually takes that arc and cuts it right in half too. So how about measure of DE? Is this the one that's asking about arc length, or is this the other one? Do you see the word length in there? No, so it's not asking for that, it's asking for the central angle. Well, where's arc DE? Well, I just traced it fairly well right there. So I need to find the central angle. Remember from the other day, that's what you got to find? Well, how am I supposed to find that? Well, I give you 30 down here. That's a right angle, so how much is this one where I just put the green dot? It's got to be 60. And then over here, oh, well, this is the same, so this one over there is 30. And this one in here is 60. So what is the central angle that makes that arc? 120. Because it says nothing about arc length, so all you have to do is find the central angle. Okay. Any questions so far? No? Okay. So once again, in a circle or congruent circles, so it could be two separate circles, two chords, there's that if again, with two F's. Two chords are congruent if and only if they are equidistant from the center. You remember a long time ago, this was probably about 3 chapters ago, if we had to go from a point to a line to get the distance, we made the dotted lines like this and made it a right angle. Do you remember doing that? Or kind of did it like this, and that's how we would do it. So that right there is a distance, and that right there is a distance, so because it's the right angle. All right? And are they the same? Yeah. Do we know what it is? No, but we know it's the same. What did we just learn about something that comes from the center and it hits at a right angle? What's it do to the chord? Cuts it in half. So in other words, that's the same as that, and well, that's the same as that. Why did I have to go back and put 2 marks instead of just 1? I caught myself there. Why did I have to go back and put 2? Yeah, exactly. These here are already using up 1, right? Okay. Okay, so we're supposed to determine the measure of arc CD. Huh. Well, it's saying that these 2 chords are the same because they're the same distance from the center. So if those 2 chords are the same, these 2 arcs are also the same. So to find the measure of CD, I could just find the measure of AB if I wanted to. Which one's probably easier here? Well, I think AB is probably easier to find. So basically I have to find the central angle. There it is, right? Because that's the one that creates this arc. 50 is right there, 90 is right there, which the green dot is 40. So over here the green dot is 40. So arc AB is 80 degrees, so what's arc CD got to be? 80. Again, the word length does not show up. Okay. So if they're the same distance from the center, they're going to be equal chords. And if it hits at a right angle like that, cuts it in half. Think those are important things to remember? Probably. Just checking. All right. Name an arc congruent to QR. Well, what does this do again? It's coming from the center and hits at a right angle, right? So what's it do to the chord? Cuts it in half. So that's the same as that. And remember what it says is it also cuts the arc in half. So this arc out there is going to be congruent to which one? Can you go QM or MQ? Does it matter with arcs? Not really. Remember, congruence was always that tricky one. You had to watch out your order. But these are arcs, so it doesn't really matter. So arc QM is correct. Any questions why QM is the one that's the same? No? So this is important right there, that hitting at a right angle. That's big. But it has to come from where? It has to come from the center. It just can't come from any old place. Well, let's fill this in. PR is 13. Where's PR? Oh, here it is. 13. RM is 24. I'm going to have to erase some of this stuff, I think. And that's probably a bad color. RM is 24. Determine that. Huh.
Excuse the interruption. Teachers, at this time, would you please excuse the high school band and choir students? Thank you.
Any ideas about how to solve this one? There's a lot of numbers up there. PJ? Oh, yeah. RO is 12. That's 12 because it bisects it. Very good. Yeah. Let's just do Pythagorean theorem. Could you try, SOHCAHTOA and all that stuff? Yeah, that would help you find the angles, but do I want angles here? No. We could do that, but we don't need to do that. Basically, what we're looking at then, this is 13, that's a right angle, that's 12, and I'm basically asking you for that, right? Does anybody remember this triple? It is 5. It's 5, 12, 13. But how would you do it if you couldn't remember that? Well, you would say x squared plus 12 squared equals 13 squared. And how did I know 13 went where it did? Because it's the hypotenuse. Okay, so it's always kind of sitting there by itself. And again, we'll solve this for those that maybe couldn't remember. That'd be 5. But you might want to start learning some of those triples because that took a lot less time, right? So subtract 144. So x squared equals 25 square root. So x is technically, algebraically, positive and negative 5, right? But does negative 5 make sense in what we're dealing with over there? No. And so that's why it ends up being 5. Very good. So name a segment congruent to segment PM. Get that stuff out of the way. Anybody think they see one that has to be congruent to PM? RP. Okay, well, how do we know that? Well, PM is a radius, so is RP also a radius? Mm-hmm. Yeah, this is one most people miss because it's kind of in the center of all the action here. And people forget that this would actually technically also be the same. And that is PQ. PQ is also a radius. Again, yeah, it's in the center of all the action there, but it still is a radius. So keep that in mind. And technically, if I wanted to in this problem, I could ask you for OQ. If you put all this information together, you should be able to tell me how far it is from O to Q. Because we know from P to Q is all the way is 13, right? And we learned that this is 5, so could you find that one out there if you had to? Yeah, it's how much? It's 8, right? Okay. All right, this is at times the hardest type. What I'm going to do is I'm going to get it drawn for you, and then you'll kind of have to finish it yourself. I think drawing these is the hardest part, but I pretty much draw them the same every time whenever I get a problem similar to this. So it says there's a chord, PQ. So here's what I normally do. I just put my chord right down here. P, Q, and of course when you do it, the sound effects are optional. And then it says the circle, it's circle O. What does that mean? It means the center is O. All right, we'll put O there. And it tells us that PQ is 24 inches long, so we'll just make a note of that that's 24 inches. And the distance, O to R, from the center to PQ. So it's a distance from that point to this line. And how do we do that? From a point to a line, how do you do distance? Like we did 3-4 chapters ago. Remember, we kind of did it like this, and you hit at a right angle. That's why I always put my chord down at the bottom so we can just go straight down with our distance. It tells me that is how much? 5. So where exactly does this R that they're talking about right there, where does that go? Yeah, somebody's pointing right there. Yeah, that's where R goes, right? Because that's OR is 5. Then. It would like me to determine OP. Does this problem look vaguely familiar now that we have it drawn out? Yeah, well, didn't we just do pretty much this problem? Really close, right? And in that problem, we were told that our chord, because let's face it, this is hitting at a right angle right here, so it takes the chord and cuts it in half. So could we go 12 and 12 again? Yeah, and there's 5, so it's 5, 12, 13. And this would be 13 inches because this one does have a label. So once you get it drawn, was it really that hard? No. Do you think maybe drawing it could